Family number 2 is your pi over 4 family. And some of you are mentioning, do we need to know our special triangles? Well, yes and no. Our special triangles, so they're for 45 degrees, you can make a special triangle for 45 degrees, which is a right angle triangle where one of the angles is 45 degrees. Well, the other angle would be 45 degrees as well. And if you have that triangle, what kind of triangle is it? Not only is it a right triangle, but it's also isosceles. And what do we know about isosceles triangles? Not only are the two angles the same, but the two sides are the same. So with that special triangle, we could pick any value we want for this side, and we would know that the other side is the same. So if you chose 1, then this side would be 1. And if you did a squared plus b squared equals c squared, this side would be the square root of 2. Now, before we write things down from that special triangle, we're going to label the easy parts of our 45-degree family first, which are the degrees and then the radians. Degrees first. So what makes something part of the 45-degree angle family? Every reference angle is 45 degrees. So if we go to quadrant 2, this angle will be 135 degrees. In quadrant 3, 180 plus 45, 225 degrees. And in quadrant 4, 360 minus 45, 315 degrees. What is 45 degrees in radians? Pi over 4. And so to find this angle in quadrant 2, you could do, you know how in degrees you went 180 minus your reference angle? 180 minus 45 is 135. So we could do pi minus pi over 4 for the angle in quadrant 2. Yes?
Is there a simpler way to find out that 45 degrees is pi over 4 than like actually doing the formula?
Well, there might be, I mean, this is going to be one by the end of the year. You're going to say, I've always known that 45 degrees was pi over 4. You're going to use it that much that you're going to be that comfortable with it. Looking at our picture, 180 degrees is pi, right? Can you see that this is split into 4 equal sections? Is that an easier way to figure out that that's pi over 4? Maybe. Is that an easier way to figure out that this is 3 pi over 4? Maybe. Can you see that if you do subtract this, how do we subtract fractions? We would need a common denominator. So pi is really 4 pi over 4 minus 1 pi over 4. You would get 3 pi over 4. Here, if you did 4 pi over 4 plus pi over 4, you would get 5 pi over 4. But if you look at the picture, could you see that that is 5/4 of the way around? So that also could help you figure out 5 pi over 4. All the way around is 2 pi. And 2 pi is equal to 8 pi over 4. So if you subtracted 1 pi over 4, this will be 7 pi over 4. Now, where our special triangle really comes in is with our coordinates. So we need to write coordinates here, 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 and here on our unit circle. And for 45 degrees, your x coordinate is cos. Your y coordinate is sine. That's our big idea. So from our special triangle, can we figure out what sine of 45 degrees is, what cos of 45 degrees is, and what tan of 45 degrees is? I'll just erase this. Well, sine is opposite over hypotenuse. And so the opposite side in the triangle that I chose is 1, the hypotenuse is root 2. And in grade 12, you can leave a square root on the bottom. You do not have to rationalize your denominator. However, in this case, we're going to. So if I multiply the top and bottom by root 2 to rationalize, can you see that that will equal root 2 over 2? And cos of 45 degrees is also 1 over root 2. So cos of 45 degrees is root 2 over 2. And tan of 45 degrees, 1 over 1 is just 1. The important thing to realize here is when you make your isosceles triangle, we chose the value of 1. Okay? And someone's wondering, well, what happens if I chose the value of 2? Would it be wrong? Would it still work out? So just for fun, let's choose the value of 2. So if I chose here 2 instead of 1, a squared plus b squared equals c squared would give me the square root of 8 for my hypotenuse. The easiest one to see that it's going to be the same as tan. Can you see that tan of 45 is still going to be 1? Now it'll be 2 over 2. Okay? For sine of 45 degrees now, and you don't have to write this down, would be 2 over root 8. If I rationalize this, I'm going to get root 8 and root 8, 2 root 8 all over 8. What can I do to simplify that? I can divide by 2, and then I would get root 8 over 4. What else can I do to simplify that? I can simplify the square root, right? Root 8 is equal to 4 and 2, so the 4 becomes 2 root 2. Now what can I do? Divide by 2 again, and I get root 2 over 2 again. Whoa. Yes?
If you left it in like
Unsimplified form? Full marks.
with any numbers.
Yes. So you do not need to simplify square roots or simplify fractions in your work. However, multiple choice questions will almost always have the answer in simplified form. Right? So I've seen questions where the answer from your triangle is like, what's the hypotenuse? And you would say root 8, and it's a multiple choice question, and the only answer that would match is 2 root 2. So you still need to know how to do it, and they assume you are experts at it already. But when you do your work, they're saying, okay, you could leave your answer. So now that we've looked at our special triangle and we talked about some extra math in there, we can now label our coordinates. And in quadrant 1 with 45 degrees, what's sine of 45 degrees? What's cos of 45 degrees? Well, cos is your x coordinate, so that will be root 2 over 2. Sine is your y coordinate. Well, that's also root 2 over 2. This one was a little bit easy because both sine and cos are the same. But then when you go to quadrant 2, two things happen. First of all, does it make sense that on the unit circle that's exactly the same height? So does it make sense that this will be the same y coordinate? And can you see that it's the same distance but towards the left? What does that make our coordinate here? Negative. And here, can you see you're going to the left, so that has to be negative, but now you're going down. And if I'm going down, my y coordinate's going to be negative. Oh, this is exciting. And over here, my x coordinate is positive. My y coordinate is negative. And so the fascinating thing about this is the coordinates of your unit circle for sine and cos just explain the cast rule. Can you see it? In quadrant 1, both sine and cos are positive. In quadrant 2, your x-coordinate is negative. That's cos. Cos is negative in quadrant 2, but sine is positive. In quadrant 3, both sine and cos are negative because both the x-coordinate and the y-coordinate will be negative. And in quadrant 4, the x-coordinate is positive, cos is positive, but your y-coordinate, sine, is negative. And then if we use the big idea for tan, so here we'll do tan of pi over 4, we know that that's 1. You can see it if you do sine divided by cos. They're the same. You can also see it from your special triangle. And then what happens when you do sine divided by cos in quadrant 2? It's negative 1. And when you do sine divided by cos in quadrant 3, oh, the cast rule again is explained. It's positive 1. And finally, tan of 7 pi over 4 is equal to 1. And now we can do mental math with the entire pi over 4 family. What is sine of 7 pi over 4? Who was the last person to go last class? Arian? Okay, you get a pick. Yes, there should be a negative on that last one if you didn't get that. And our next family, pi over 6. So we'll start by labeling our degrees. The pi over 6 or 30-degree family is right there.
Sorry for the interruption. Mr. Tacky, you have an urgent call at Quadrant 100. That's Mr. Tacky, Quadrant 100.
Quadrant 2 with the same reference angle would be 150. Quadrant 3, 210. Quadrant 4, 240 degrees. No, 330 degrees. In radians, quadrant 1 is pi over 6. I'll give you a 15-second head start to do the other 3. How did you do? Did you get 5 pi over 6, 7 pi over 6, and 11 pi over 6? Now you have some space in this area of your paper, so I would like you to, in this space, write special triangle for 30 degrees and 60 degrees. Why is it both? Well, if you draw a right angle triangle and you label one side as 60 degrees, or one angle as 60 degrees, since they add up to 180, the other angle has to be 30 degrees. Now, in our first triangle, we recognized it as a right angle triangle, but it was special for another reason in that 2 sides were the same and 2 angles were the same, and we gave it a special name. It was an isosceles triangle. This triangle, the angles are all different. The sides are all different. In reality, it's not very special at all. We have a special name for not special triangles. Do you know what the special name for not special triangles is? No, you don't even remember them. You don't care about them. They feel bad their whole lives, and you're like, oh, come to an, ooh, nice equilateral, nice isosceles. But what are these ones called? Just triangles. You're like, just lump them together. You're just like below average triangles. What do we call them? They're kind of fishy. That's a hint. They're kind of fishy. They're not mackerel triangles. Scalene. Ugh. Even the name makes you feel like I don't really like these triangles. So this is a scalene triangle. It's spending its day feeling bad about itself because it's not special. I know it's a sad story. And it comes across another scalene triangle feeling the same way. not special. And they're like, I'm not special. And the other one says, I'm not special either. And they're like, well, you want to be friends. And so these two scalene triangles came together to be friends. And then when they got together, something special happened. Whoa. What happens when you put these two not special triangles together? They become special. Why do they become special? What is the whole thing together? It makes an equilateral triangle. And once they're together, if they're an equilateral triangle, you know all the sides are going to be the same. Now we could pick any value around for all the sides, but I'm going to choose 2 here and 2 here. That means the whole bottom is 2, but when it's split into 2 parts, this side's going to be 1 and this side's going to be 1. Does that make sense? And now you have enough information to do a squared plus b squared equals c squared. 1 squared plus something squared equals 2 squared, which makes this the square root of 3. And all of a sudden, our not special triangle, we can, just by the properties, figure out sine, cos, and tan. We'll do the 30 degrees first, sine of 30 degrees, cos of 30 degrees, tan of 30 degrees. And then we can do sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees. Looking at our 30-degree angle, sine is opposite over hypotenuse, 1 over 2. Cos, adjacent over hypotenuse, square root of 3 over 2. And tan, opposite over adjacent, is 1 over root 3, but we are going to rationalize for now and write it as root 3 over 3. Sine of 60 degrees, well, now that is opposite over hypotenuse of the 60 degree. It will be root 3 over 2. Cos of 60, 1/2. And tan of 60, root 3 over 1, which we'll write just as root 3. So with that special triangle, we can now go to our 30-degree circle, label our points on the unit circle where the reference angle is 30 degrees, and say, what is cos of 30 degrees? Root 3 over 2. What's sine of 30 degrees? 1/2. So over here, the exact same points, but now our x-coordinate is negative. Here, exact same points, but now both our x-coordinate and y-coordinate are negative. And finally here, our x-coordinate is positive, and our y-coordinate is negative. And from our special triangle, tan of pi over 6 is root 3 over 3. You could also do 1/2 divided by root 3 over 2 and do a fraction divided by a fraction, multiply by the reciprocal, simplify to get that as well. Tan of 5 pi over 6, because it's in quadrant 2, will be negative root 3 over 3. Tan of 7 pi over 6, because it's in quadrant 3, will be positive root 3 over 3. And tan of 11 pi over 6 will be negative root 3 over 3 again. By now you're getting pretty good at these. I'm going to give you a 10-second head start to do all the degrees. How did you do? 120 degrees, 240 degrees, and 300 degrees. In radians, 60 degrees is pi over 3. 10-second head start for your radians. 2 pi over 3, 4 pi over 3, and 5 pi over 3. And finally, I'll get you to do your coordinates and tan. Okay, coordinates. 1/2 root 3 over 2. Negative 1/2 root 3 over 2. Negative 1/2 negative root 3 over 2. And 1/2 negative root 3 over 2. And tan of pi over 3 is equal to root 3. Tan of 2 pi over 3 is negative root 3. Tan of 4 pi over 3, positive root 3, and tan of 5 pi over 3, negative root 3. Quadrant 1 is pretty easy to figure out where the, if it's pi over 3 family, quadrant 1 is pi over 3. If it's the pi over 4 family, quadrant 1 is pi over 4. But if I wanted to switch to a family, for example, let's say I switch to quadrant 2. What's the pi over 6 in quadrant 2? Without looking. Let's figure out a way that we can do this quickly without looking. Pi over 6 in quadrant 2? 5 pi over 6. The quadrant 4 in quadrant 2? 3 pi over 4. The pi over 3 in quadrant 2? 2 pi over 3. What pattern do you notice with each of those? One less than the denominator. For pi over 3, it's 2 pi over 3. For pi over 4, it's 3 pi over 4. For pi over 6, it's 5 pi over 6. Okay, that makes sense because if you would do pi, which is 6 pi over 6, minus the reference angle, which is pi over 6, you would take away 1. Okay? Let's look at quadrant 3. What pattern do we notice in quadrant 3? The pi over 6 in quadrant 3? 7 pi over 6. Pi over 4 in quadrant 3? 5 pi over 4. The pi over 3 in quadrant 3? 4 pi over 3. What do we notice about a pattern? One more.
So, like, what are you actually finding?
I'm finding what is the pi over 3 family member in quadrant 3. So if I ask, what is the pi over 6 family member in quadrant 4? 11 pi over 6. What is the pi over 3 family member in quadrant 4? 5 pi over 3. What is the pi over 4 family member in quadrant 4? 7 pi over 4. How could you find those ones out quickly? What's the pattern with 11 pi over 6, 7 pi over 4, and 5 pi over 3? What's that? One less than double. And again, that should make sense because if double is 2 pi is double, right? If I take my pi over 3 family, 2 pi is the same as double that, 6 pi over 3, right? And if you subtract one reference angle, you'll end up at 5 pi over 3. Okay? Because we're going to need to know all of these values all together, because we're going to have a quiz on this on Friday.